Understanding Blockchain Technology, a comprehensive beginner's guide. What is blockchain technology? Blockchain technology is a decentralized and distributed digital ledger system that records transactions across multiple computers. Here are some key characteristics and components of blockchain technology. Transparency. The data stored in the blockchain is accessible to anyone on the network. Use cases. Blockchain technology has a wide range of applications beyond cryptocurrencies. How does blockchain work? Understanding how blockchain works involves delving into the underlying mechanics of this technology. Data structure. A blockchain is a distributed ledger made up of a chain of blocks. Network copies. Each node in the network maintains a copy of the entire blockchain. Smart contracts. Some blockchains, like Ethereum, support smart contracts. Blockchain versus traditional databases. Blockchain. Decentralization. Blockchain is a decentralized system where data is stored and managed across a network of nodes. Security. Data in a blockchain is secured using cryptographic techniques. Traditional databases. Centralization. Traditional databases are typically centralized, with a single entity or server responsible for data storage and management. Security. While traditional databases use security measures like access controls and encryption, they are generally more susceptible to hacking or unauthorized access compared to blockchains. Decentralization. The core principle. Decentralization is a core principle of blockchain technology and one of its defining features. It refers to the distribution of control, authority, and data across a network of nodes rather than relying on a central authority or single point of control. If one node on the network fails or is compromised, the network can continue to operate because other nodes maintain copies of the data. Cryptography in blockchain. Cryptography plays a fundamental role in blockchain technology, contributing to the security and integrity of the data and transactions within the system. Data encryption. Cryptography is used to encrypt sensitive data in a blockchain, such as transaction details, to protect it from unauthorized access. Public and private keys. Blockchain users have a pair of cryptographic keys: a public key, which is visible to everyone on the network, and a private key, which is kept secret. Consensus mechanisms. Consensus mechanisms are at the heart of blockchain technology. They are the protocols and algorithms that ensure that all nodes on a decentralized network agree on the state of the blockchain. Here are some common consensus mechanisms. Proof of work, POW. POW is the original consensus mechanism used in Bitcoin and many other cryptocurrencies. Proof of stake, POS. POS is an alternative to POW. Byzantine fault tolerance, BFT. BFT is a family of consensus algorithms that are designed to be highly fault tolerant. Nodes and network participants. In a blockchain network, nodes and network participants are fundamental components that play distinct roles in the operation and maintenance of the network. Nodes. Definition. Nodes are individual computers or devices connected to a blockchain network. Network participants. Definition. Network participants are individuals, organizations, or entities that interact with the blockchain network by sending and receiving transactions. Public blockchains. Public blockchains are open and accessible to anyone. Anyone can participate in the network, validate transactions, and create new blocks. There are no restrictions on who can join. Private blockchains. Private blockchains are permissioned networks, meaning that participation is restricted to authorized entities or individuals. Hybrid blockchains. Some blockchain networks combine elements of both public and private blockchains. Blockchain use cases. Identity verification. Blockchain can be used for secure and decentralized identity management. Cross-border payments. Blockchain technology can facilitate cross-border payments by reducing the time and cost associated with traditional banking systems. Conclusion. In conclusion, blockchain technology is a transformative innovation with the potential to disrupt numerous industries and change the way we conduct transactions, manage data, and establish trust in the digital world. The choice between public and private blockchains depends on the specific needs and objectives of an application, and in some cases, hybrid solutions may offer the best of both worlds. As blockchain continues to evolve and address challenges related to scalability, security, and regulatory concerns, it is poised to reshape the digital landscape and bring new opportunities for innovation and decentralization.